Hello. Today we're going to talk about Topic 5, Section 4, Tangents and Normals. Okay, so a tangent is that tangent line that is tangent to a specific point of a graph. Okay, so here you have some random graph. Your tangent line would be that. Okay, this single line. So let's start with what this means. So verify that this point is on that graph. Okay, well that means this has to be x and that has to be y. So 1 must equal log of 6 plus 2 squared. Well, does 1 equal log 10? Yes. Okay, we can use our calculator. Hopefully we know that. Okay, if not, the calculator's there. So now the next part, we want to use the calculator to find the equation of the tangent to this graph at this point. Okay, so here we know this is our point. Well, what else do we need to make a line? We need the slope. How do we find the slope? We use the gradient. So I get out the calculator. I'm going to my stat plots, my y equals, and I'm going to put in my equation. So log of 6 plus x squared, and then I can graph it. Give it a minute. And now I want to find the tangent, the derivative, the gradient, the slope. So go to second trace. I go to dy over dx, which is just 6. And I want to do that at the point, what did I have? 2, 1. So when x is 2, so then hit enter. Now we've got our slope, so that is 1737. Okay, so our gradient was 1737. I have no idea. Did I remember that correctly? Yes, okay. So that was decimal, so 0.1737. Okay, roughly. So now we want to find the equation. Well, there's a couple ways we can go about this, but essentially we would like the equation to be y equals mx plus b. Well, our gradient is just a fancy way of saying m, and we have our point. So 1 equals 2 times that 0.1737. Then we figure out what b is, and then we can use our equation. Let's see if we're right. There we go. So when you solved, you should have gotten b equals 0.653. So solving this on your calculator gets you b equals 0.653. And over here, notice that's our gradient, and that was our y value. Our b value. There we go. Okay. Notice they used 3 significant digits. I went a little bit further out. The more decimals you have in your calculator, the closer your value at the end is. Okay, so I always try to save all my rounding for the end. Alright, so let's do this one. The diagram shows part of the graph. Let's see, it shows a point, okay, and with the x-coordinate and the tangent. Okay, so what do we want to find? We want to find this, the equation of the tangent. Alright, well, we know the x value is -1. That's all I got. Well, I can figure out the y value by plugging it in, right? I've got my equation up here. So let's figure it out. Y equals, we could do -1 cubed minus 2 times -1 squared minus 5 times -1 plus 6. So what do we get? -1 minus 2 plus 5 plus 6. So why am I not doing that right in my head? 3, then that's 2, so 8. So our point is at -1, 8. Awesome. So I'm close to finding my tangent line. I've got my point. Now I need my slope. Well, let's find our gradient. So find our derivative of that equation. Hopefully we remember this is just 3x squared minus 4x minus 5. Okay, using those power rules. So this is our derivative. We want to find it when x is -1, so plug in -1. 3 times -1 squared minus 4 times -1 minus 5. So we get 3 plus 4 minus 5, so that's 2. So remember, that is our derivative, our gradient at x is -1. So plug in our equation. We've got y equals mx plus b. Yes, you can use point slope formula, but I find a lot of people don't remember it. So let's plug in 8 equals our slope times -1 plus b. So -2, so we get 10 is b. So it looks like our equation should be y equals our slope plus b. Let's see how we did. Oh. There we go. Sorry, my computer froze. Ooh, I have no idea what I just did. Okay. Fancy. Alright, so yep, we got 2x plus 10, so we did good. Alright, let's keep it rolling. Okay, so here we've got our equation. We've got the line 27x plus 6. That's this red line. So I'm going to go ahead and write that in right here. This is y equals 27x plus 6, and the blue line, sorry, I like to be color coded, is this one. Okay, ooh, I kind of wrote all over the exponents. Okay, so we'll just do it like this. So a point is on the graph, and let's see, and the line and the tangent to the curve, the point B, that's parallel to this line. Okay, so those are parallel. That's probably good to know. So we want to find the gradient of the two lines. Okay, well, the gradient's fancy word for saying slope. Slope of both lines, since they're parallel, they have to be equal. That's pretty easy. Hopefully you can tell by the red one that the slope is just 27. There we go. We want to find the coordinates of P. So let's do that. Okay, so our gradient must be the same. So let's look at our other equation. What is the derivative of that equation? So let's see, let's keep the terminology the same. dy over dx. So let's see, what do we have? 3x squared minus 4x minus 5, same one as before. So that derivative must be the same slope as the other line. So 3x squared minus 4x minus 5 must equal 27. 3x squared minus 4x minus 32. Okay? Oh, took me a second to think about it. But it does factor. You can use the quadratic formula, you can factor, or you can plug it into your graphing calculator. So it should be 3x minus 8. What is that? X plus 4, I believe. Minus 8, 12. Nope. I lied. I didn't lie. I just misspoke. Okay. It should be 3x plus 8, x minus 4. There we go. So the two x values that you get is -8/3 and +4. All right. Well, look at where it is on my graph. Okay. This represents my x value. And it doesn't really make sense for my x value to be over here because I'm in the first quadrant. So we're going to rule out the -8/3 and stick to x being 4. So at this point, we're at 4 comma what? Well, plug it into your original equation. Y equals 4 cubed minus 2 times 4 squared minus 5 times 4 plus 6. So what is that? 64 minus 16 minus 32 minus 20 plus 6. So 32, 12, 18. So we're at the point 4 comma 18. All right, let's see how we did. Sweet, we got it. All right, so now we're going to find the equation of the tangent. Okay, well that's great because we just figured out everything. We've got the point and we've got the gradient, the slope. So we can just plug all that stuff in. We get 18 equals 27 times 4 plus b. Remember, I'm trying to do y equals mx plus b. So now I have to think, what is that? 40, 54, yeah, 108. So 18 equals 108 plus b, so subtract 108. We should get negative 90. So our equation should be y equals 27x minus 90. Oh, I hope I'm right. Oh, there we go. Perfect. All right, let's keep it going. So here we've got our graph again, and now we've got a point not on the graph, and we know it's tangent. So find the equation of this tangent. Well, we need to know what this point is, okay? So I'm going to just call it something, right? Plug in something. I think your textbook just plugs in the value d. So if I plug in d, that's my x value. My y value is going to be d cubed minus 2d squared minus 5d plus 6. Okay? So I want to find, now I've got a point. I also need my slope. So there's two ways I can find my slope. One, I can just do my derivative of my original function. So remember, we've already got that, 3x squared minus 4x minus 5. So I know that my slope must be this. And this is my point. And this is my point that I'm going to plug in. Well, I could also find my slope by using my 2 points. By what I mean by that is, what's the change of y over the change in x's? So subtract your y's and subtract your x's. Take this y minus this y. So d cubed minus 2d squared minus 5d plus 6 minus 2 all over d minus negative 4. So another way of getting that change of y over change of x, so we end up with d cubed minus 2d squared minus 5d plus 4 all over d plus 4. Do not do that. You cannot do that. That is a bad rule. You cannot do simplifying with adding and subtracting. Okay? Do not do that. Okay. Now let's go back. We have this represents our slope, and this also represents our slope. So if I were to plug in d into that equation, that would tell me my slope at that particular value, which would be 3d squared minus 4d minus 5. You with me? Okay. Oh, I can't move it. So let's work that out. Okay, so I had to fix that. There's two ways. So starting over, there's two ways to solve this now. Okay, we can solve it as a polynomial. So that means get it all on one line. So move this d plus 4 to the other side. So what I mean by that is do d cubed minus 2d squared minus 5d plus 4 equals 3d squared minus 4d plus 5 times d plus 4. Okay, so literally write that out. Let me do that real quick. Okay, so I know a whole bunch of things just popped up on your screen. What I did was I just FOILed this, so I distributed the d to everything. Then I distributed the 4 to everything, and then I combined my like terms. And then I moved everything from the left side over to the right side. So I got this. Okay, so now we can plug it into our calculator. So we go to Apps, the Poly Simulation, Polynomial Root Finder. So here we have 3 orders. We want to find the fractions. There we go. So we're good here. So we list our coefficients. We've got 2, 10, -6, and 16. So then we solve. Okay, I got something gross. What did I do? Hold on. Okay, I just saw what I did. I had a +5. Hopefully you didn't do this. So then that changes this. Oh my goodness. Okay, so many things. Okay, so I messed up the 5D, so then that messed up everything pretty much after that. Okay, sorry y'all. Thought I had it. Okay, that was a minus. See, I'm human. I make mistakes. So -5D, then this is -20. Okay, so now we get -21D -20. So, yes, hopefully this works now. Okay, so I made another mistake. I forgot to move that 5D and 4 over. So now this is what you get. Ugh. So now when I plug it into my graphing calculator, okay, so now when I put my coefficients in correctly and I hit solve, I get 3 answers, -6, 2, and -1. So here, D is either -6, what did I just say, 2, or -1. Doesn't matter the order, I'm just writing them out. Okay, that was one way to solve it. Another way to solve it is that you can find the intersection of those two equations. So like if I go to my graph, sorry, let me exit out of this. If I go to y equals, notice I put in my derivative equation and I put in my slope equation. I just changed it from d's to x's. So this is my first line in blue, and this is my second one that's going to be in red. So then when I hit graph, all right, here I can find the intersection of those 2 points, okay, and that's going to tell me what D represents, okay. So finding that intersection, you can do that by doing trace. Oh, I lied. What is it? Second trace? Yeah, second trace. 5, go for intersection. You go the left of it, the right of it. You guess, you just kind of follow these amounts there. Okay, so what is D? Well, D was our x value of our point. Well, it's either -6, -1, or 2. Well, -6 is to the left of -4, so that one can't be it. So let me go ahead and... that one can't be it. 2 would be in the first quadrant, but my point is not in the first or fourth. I guess I should say it should be over here, which it's not. So we can cross out 2. So it's got to be -1 based on graph. Okay. So now we know what the x value is. So plug it in to find your y value. Plug it into your original equation. So figure out y by plugging in -1 cubed minus 2 times -1 squared minus 5 times -1 plus 6. So we get -1, not plus 2, silly miscross. Okay, -2 plus 5 plus 6. So we get -3 to 8. That seemed really familiar, so I was... yeah, anyway. Anyway, so now our point is -1 comma 8. So this is important to know. Okay, so that's what that point is. Now to figure out what the gradient is, our slope, well, we get that from our derivative. So let's plug that in. So we're going to get 3 times -1 squared minus 4 times -1 minus 5. So we get negative 3 plus 4 minus 5. So our slope is negative 4. So now we can find the equation. So 8 equals negative 4 times negative 1 plus b. So we get b is 4. So now our equation is y equals negative 4x plus 4. Oh, I hope I'm right. That was a lot of work. What? Why do I keep pressing that button? Okay, sorry. Ugh, I did something silly, didn't I? Hold on, let me find my mistake. Okay, well, I feel really silly because I did 3 times negative 1 squared is not negative 3. Hopefully you caught that. Such is life, such is life. All right, sorry about that, y'all. So 3 plus 4, okay, so now our slope is 2. So we plug that in. We get b is 10. So now our equation is this. Oh, and I didn't erase the negative 4 because our slope is now 2, not negative 4. And I should have realized that too because that is clearly not a negative slope. Okay, I should have realized that was a positive slope. We all make mistakes. All right. All right, so hopefully by now you've had time to pause the video, read the problem, know what it's talking about, okay? So the first thing I like to do is I like to label things. So here we've got these points. So I'm going to put 0, 3.05 and 2.36, 4.01. And where he is 4.87, 2.22. Okay, so the 3 points on the path of the ball, we've got those. The equation is here. So find the values of A, B, and C. So this is something cool that your graphing calculator can do. So here, these 3 points are just any x and y, right? So we can plug those into our equation one at a time. So let's plug in this one first. So we're going to place y with 3.05 equals a times 0 squared plus b times 0 plus c. Well, that's really cool to see because, really nice to see because we get 3.05 is c. Great, so we've already got one of our variables done. All right, so now we plug in the next point, 2.36, 4.01. All right, so the y is 4.01. And instead of writing c plus c, the equation here. So instead of writing just c, I already know what it is. I'm going to put plus 3.05. Okay? And then my third point, get 2.22. Okay, so I'm going to rewrite my equation, and I'm going to move those 3.05s over. So I'm going to do 4.01 minus 3.05, and I get 0.96 equals a 2.36 squared plus b times 2.36. Then move my 3.05 over again for my next one, and I get negative 0.83. Again, I just know you guys like to visualize this. Okay, I could square those numbers, but I know they're going to be gross, so I'm just going to leave them like they are. And then I'm going to get out my handy-dandy calculator, and I'm going to go to my apps, and I'm going to go down to my poly simulation, so number 4 on this calculator. press any key, and I'm going to go to the simultaneous equation solver, right? Because I've got several equations and several variables. So number 2. I have 2 equations, 2 unknowns. Go to the next one. Then I'm going to put them in like a matrix. In this one, it wants me to. So I'm going to start with my variables. So I'm going to do A, B, then what it equals. A, B, then what it equals. Just the coefficients. So this one is 2.36 squared. The next one is going to be 2.36. I guess it's already in here. And then it's going to equal 0.96. Going through the motions. Okay, then we do it again. So here we've got 4.87 squared for the A here. Then 4.87 for the B. And then negative 0.83. Okay, so then you're going to hit solve, which is the graph button. Okay, so I get two gross numbers, but the first number that I get represents my first variable I put in, which was A. My second x that solves for is my second variable, which is B. Okay? So, oh, I didn't even write the answer. So A would be here. What's going on? Okay, so the next part, what I would do is we want to find the tangent line, all right, where the ball reaches the center of the hoop. Well, that tangent line is going to be at this point. So we want this line. So we start with our original equation that we just found. Notice it's by equals ax squared plus bx plus c, but I replaced my a, b, and c, right, with what I found in the last problem. All right, so if I want to find the slope at any point on this equation, I find the derivative. So I do the power rule. So this is my slope, and I want my slope at this point. So I'm going to plug in my x value, which is 0. I plug in 0, and I get 0.949. That's my slope. So now I've got my slope and my y-intercept. Well, now I've got my equation of the line. Y equals mx plus b. Oh, I moved the wrong one. Okay, so again, that was y equals mx plus b, where m is your slope, which we found using the derivative, and our b is our y-intercept, which is given, right? It's our point. So we looked out there. The next one, this problem's a little bit weird, I'll be honest, and you have to kind of remember some old skills. So this would be more of like a bonus or kind of an extra. So this wouldn't be one of your main problems on the test, okay? But it's pretty simple to do. It's a little bit trickier to visualize. So here you want to find at what angle does the ball reach the center of the hoop. So what I'm going to do is, I'm going to draw a little larger than that. Okay. What I would do is, we know it reaches the center of the hoop here, and we want to know what angle it makes with the ground. Well, we found that line by doing our slope, right? Doing our tangent line. So here, if we extend it, we've got this nice triangle. All right, and we want to find the angle made with the ground. All right, so where we see that ball hitting the hoop from the ground. Okay, how far up you got to look, basically. Okay, so we know that this is the distance we run, and this is the distance we rise. And hold on, this whole lesson is called, I don't know, tangents, right? So the tangent of my angle, remember, is opposite over adjacent, SOHCAHTOA. So tangent of theta is opposite over adjacent. Huh. Wasn't that fancy? Look at that. Rise over run. Another fancy way of saying slope. So the tangent of theta is just equal to your slope. And if we want to get theta by itself, well, the opposite of tangent is just the inverse tangent, or arctangent. Remember, with the little -1? So if we take the inverse tangent of our slope, we get the angle it makes with the ground. All right, that's your little shortcut. The inverse tangent of your slope is the angle it makes with the ground. Okay, so the inverse tangent of my slope, what was my slope again? Oh yeah, that line, that tangent line, which was here, and there's our slope. So inverse tangent of 9.49 is just, let's get out my calculator. This is going to give me what my theta, my angle. So hold on, let me exit out of this. Quit app. 6. Okay. So inverse tangent, we will need to do second tangent. Right? That's how we get that little -1 up there. That means inverse. So 0.949, enter. Our tangent is, that looks awfully small. Something seems really weird to me. That's a very tiny, tiny angle, right? So let me check my mode. Anybody see it? Oh yeah, radians. I need to be in degrees, so let me fix that. Usually we talk about it in degrees. Okay, if you put it in radians, put your answer in radians. Okay, so make sure you write that. But I like to do it in degrees. So this one is 43.5 degrees. So we go back over here, and there we go. That's what we got, 43.5 degrees. All right. So the normal. Okay, the normal is just the perpendicular line to the tangent. All right, so here we have our normal function. Here we have a point. Here we have a slope. That's the tangent line. Okay, this is our tangent line. If I want to do it perpendicular, okay, this is going to be my normal. Okay, so think about your slopes. Okay, well, hopefully you remember that if this slope was, I don't know, 1/3, this slope would be -3/1, right? We do the opposite reciprocals. So that's what this is doing. The negative opposite sign of the flip of the original slope. Okay, so let's do a problem. So take a minute, pause, read this. So this one is pretty neat. We can do this with our calculator. So let me show you first with that. So I first want to look at my graph of y equals this. So I go over here and I type it in. So my log button is right here. Notice the base is 10, so I don't have to find the other one. So 6 plus x squared. All right. So we hit graph and this pops up, and then we can second trace, go to 6 dy over dx, and then we can do it at the point 2 comma 1, so we want to hit 2, and our derivative is 1737, looks like. So the derivative at 2 is just, sorry, I had trouble writing there, 1737. So we want to find the perpendicular line, so we want to find that slope. So that's going to be negative of the flip of that, so 1 over 0.1737. So that's our slope for the normal line. Okay, so now we've got our slope and we have a point. So now we want to find the rest of our equation. Again, a lot of people forget point slope formula. Most people remember y equals mx plus b. So plug in what you know. You know x is 2. You know your slope is this, and you know your y is 1. So 1 equals, all right, plus b. Solve for that, and you'll get this. There we go. This solves for b. Again, this would get you just 12.5, but then you'll have your b, your slope, and then you can plug it all in right here. Okay? So the next one, there you go. Pause it, take a minute to look at it, understand what it's talking about. So I like to label things, okay? So we know this blue line, all right, that is just our y equals 0.2x cubed minus 0.4x squared minus x plus 1.2, right? That's this blue line. Then we know our tangent line is an x-coordinate of -1, and this is your normal going through this point. So I think the first thing we should do is probably figure out that b value, all right, because that's a point on my original graph, so I can plug it into my equation. So we get y equals 0.2 -1 cubed minus 0.4 -1 squared minus -1 plus 1.2. So we get y minus 0.2 minus 0.4 plus 1 plus 1.2. So 0.6, so we get b must be 1.6. Okay, because I know that was y, but we were finding the y value here, which was b. So we know b is 1.6. So let's see, what else can we do? Well, since this is the normal, we know it's related to our tangent through the slope. So why not find the slope of this line? Okay, it's something we can do. So we start with our derivative of y. So we do our power rule trick. And we want to find it at the point where x is -1. So we plug in -1. We get 0.6 plus 0.8 minus 1. So we get 0.4. So remember that represented our slope of our tangent line. So of our slope of our normal line is just going to be the opposite reciprocal of that, which I believe, what is that, 4/10, 2/5, 5/2, negative 2.6. All right. Sorry, trying to do some mental math there. Okay. So we've got the slope of the normal. Well, we could do a couple things. We know a point and we know a slope, so we can do our line, right? Our y equals mx plus b. I'm sorry, I didn't realize I had that covered. Still showing. Sorry, ignore that. So we have y equals mx plus b, so we know our slope of our normal is negative 2.6. We know the point that goes through that normal is negative 1, 1.6. So let's use it to solve for b. So we subtract, and why am I getting something weird? Did I do my slope wrong? Why did I say 2.6? Oh, I said 5/2. There I go, making a mistake. I guess it happens to the best of us, right? Wondering. Oh wait, that's not the one I erased. This is the one I erased. Well, now I've got to fix that. Okay, try this again. This was 1.6. This is negative 2.5. There we go. So now we subtract that and we get negative 0.9. So our b value is negative 0.9, which represents our y-intercept, if you remember. Okay. If not, we now have our b, so we do have the equation of the normal being this. And so now we can just plug in 0. Same concept. Okay. There we go. Let's keep going. Take a minute, pause it, read this, see what's going on, maybe label a couple things, okay? Okay, so I labeled a couple things. I labeled the equations I had with the graphs, and I put that these lines were parallel. Okay, so the first thing I want to do is find the gradient of the normal line. Well, gradient is just a fancy word for slope. So the slope of the normal, well, that's this one. Okay, so that's parallel to this one. Well, the slope of that one is just 5. Yes, it is just that easy. Okay? All right, it's the same slope. Okay, don't overthink it. These are equal slopes because they're parallel. This one is y equals mx plus b. Okay? Okay. So now I want to find the gradient at the curve P. Well, remember that is just the slope of the tangent line, which is just perpendicular to the normal line. And since we found that out to be 5, to get the gradient, all we would need to do is take the opposite reciprocal. So the gradient should just be, there you have it, negative 1/5. Either way you write it, same thing. So let's find the coordinates of P. Okay, well, P has to go through that point, through the original graph and through your tangent. So I would, since we know our slope at that tangent line, I would just take the derivative of our original function. So let's see, let me change this. So you recall that our derivative is this, and we know that it wants to, it needs to equal this negative 0.2. So we let it equal 0. And then we use our, we're going to add 2, so it should be that. We're going to plug this into our calculator, go to our apps, then the PolySmlt app, or whatever you want to call it, simulation app. Okay, we're going to go to the polynomial root finder, number 1. There are two, it's x squared, so 2 is the exponent. Next, we have 0.6, negative 0.8, and let's see, negative 0.8. We're going to solve, and we get 2 and negative 2/3. So x can either be 2 or negative 2/3. Well, we want to find the coordinates of P. Well, that's 2 x values. Well, what makes sense? Is x going to be 2 or x going to be negative 2/3? Okay. Hopefully, looking at the graph, you can tell this one doesn't make sense. So our x value should be at positive 2. And then let's find the y value by plugging it back into our original equation. Okay, so we get y equals 0.22 cubed minus this, and minus 2 plus 1.2. So we solve this, and we should get negative 0.8, I believe. Let's hope I'm right. There we go. X is 2, y is negative 0.8. All right, so now we want to find our, so for the last question, we have find the value of a. So that goes through our normal line, which has a slope of 5, and goes through point P. So we can use y equals mx plus b again. Well, I mean, a different problem, of course. So then here we've got negative 0.8, 5, 2, b, so 10. So we get negative 10.8. So we have our equation is this of our normal line. We want to find the value of a, so when y is 0, we divide by 5. That should be 2.16. Okay, let's check it. There we have it. All right, let's do one more. Okay, getting tired, I know. Let's just hang in there. There are 2 points on the graph where the normal is vertical. Okay, find the distance between these 2 lines. Okay, so the normal is vertical, which means the tangent must be horizontal. Like how I did that, didn't you? So if the tangent is horizontal, then the slope of the tangent line must be 0. So the derivative of this equation must be 0. So 0 equals the derivative. Oh, well, here, I don't want to skip any steps. So we're going to take the derivative, and we've got this from before, and we want that to equal 0. All right, we plug that into our calculator. Okay, so we solve this on our calculator, and we can get these 2 x values, or using the quadratic formula, whatever you want to do. So at these two x values, the tangent line is 0, which means the normal line is vertical. So again, at these x values, the tangent line is 0, and the normal line, so the tangent line is horizontal. So somewhere along these lines, the tangent line is horizontal, and the normal line is vertical. So the distance between these two lines is just the distance between the x values. You with me? So we just take the difference. 120 minus negative 0.786, and that should give us our distance. And there we have it. 2.912, 3 significant figures. Okay? So this is what you should know by the end of this topic. All right, if you have any questions,